the coordinate plane. I'll be honest, this should be a review for most of you. So do me a quick favor. If you remember graphing points on the coordinate plane, please raise your hand. This is one of those end-of-year standards, so some teachers may not have gotten to this. How many of you keep your hands up if you did all 4 quadrants? So positive and negative numbers for graphing. Okay, it's almost nobody. Okay, guys, that just gives us a base. So I know with you guys, I'm going to go a little more in depth, which is probably good since we're doing the recording on this one. But please be patient. If you do understand this and you've got it, please just keep it to yourself. Follow along. If you've got questions, please raise your hand to ask. Go ahead. What'd you do?
I didn't do anything.
You didn't push it in all the way. You just didn't push it in.
Oh.
There you go. Okay. Sorry, guys, at home, we just had a major issue with our pencil sharpener. Someone decided to put their eraser in instead of the pencil and broke the pencil sharpener. But, guys, please quiet. Seriously. Today we're going to go through the coordinate plane. I'm going to jump around a little bit in the notes to try to make it make more sense to you as we're going along. So let's start with our base definition. A coordinate plane is made with 2 intersecting number lines. One is horizontal, one is vertical. The x-axis is my horizontal number line. The y-axis is my vertical number line. When they intersect, this now forms what we call 4 different regions in our coordinate plane, which we refer to as quadrants. So the 4 regions that are formed when these 2 number lines intersect are called quadrants. So just to make sure it's clear on yours, let's draw in our 2 axes and make sure that they are nice and dark. We have this axis, our horizontal. We have this axis, our vertical. Now, if I look at the letter X, does that give me any idea if it's going up, down, left, right? Not really, because it's the same all 4 ways, right? But what if I look at the letter Y? Does Y go up and down or left, right?
Right.
A Y? I didn't think that was a trick question, but apparently it is. The way I draw my Y's, it is very much up and down. Okay? So the Y-axis is actually easier because the letter actually tells you which one it is. Whichever one is left over is your X-axis. Okay? So the X-axis, yes, Emma?
My teacher last year taught me that you could do for Y yo-yo, which goes up and down.
Yep, the Y yo-yo goes up and down. So the X-axis is our horizontal number line. And the Y-axis is our vertical number line. There's also another special point, and this is where those 2 lines intersect. So if I look right here in the middle is a special point. Where those 2 axes intersect is called, Madison, you know it?
Oh, no, I have a question.
Okay, what's your question?
I kind of thought that vertical meant like, what is that word?
Slanted.
Yeah, I thought that was vertical.
No, vertical is up and down. Diagonal or slanted goes that way. Back to what I was saying. Where those 2 number lines intersect, that has a special name. It's called origin. Why? Because everything in your coordinate plane originates from that spot. And we'll talk about it in a little bit as to why this is so important when we're plotting our points. Now, who knows what I use to locate a point's position on a coordinate plane? What do we call that?
Graphing?
I use it to graph. They are called ordered pairs. Ordered pairs are used, points located on the graph. Here is the big key in this, guys, and this is critical for us to be successful for the rest of the year whenever we're graphing something, because we will be doing more graphing as the year goes on. Every mathematician in the world will do their ordered pairs exactly the same way. So there is no leniency on this. You have to do this exactly as I'm about to tell you every single time. An ordered pair is always going to start with a parenthesis. The first thing that I'm going to see in my ordered pair is my x. So the first one is telling me where on this x-axis is this point located. I then have to have a comma. The comma is going to separate. That's telling me here's where your x, here's where your y is. So that tells you the next thing is going to be your y coordinate. And then we are going to finish our ordered pair with another parenthesis. This never changes. Every mathematician in the world who looks at this is going to put that number at the same point because no one ever changes this. Is that clear? Question? Yep. It is alphabetical. X always comes before my y. The other one is you always run before you can climb. Okay? Now, quadrants, and this is where I miss Miss McShan today because we had a lot of fun with her last year. Apparently she was hungry as she was teaching this part of the lesson because what we actually have, the 4 quadrants that you see located here are always labeled using Roman numerals. However, because she was hungry, when she wrote this, she actually wrote ramen noodles instead of Roman numerals. So I will forever associate ramen noodles with Roman numerals in our coordinate plane. You can, but that would be wrong. It's actually Roman. Now, you guys have noticed the big C down here, right? Jasmine, please stop. Thank you. The big C, this is to help you remember the order for our 4 quadrants. The way this works is just like a C. Where does a C start? Up here. And a C goes just like this, right? So this is the order for our 4 quadrants. We start at number 1. What comes after 1? 2. What comes after 2? 3. And after 3 becomes... Now notice, those are Roman numerals. Yes, you must use Roman numerals because that specifically tells me you are talking about quadrants in the coordinate plane. There are other uses for Roman numerals, but this is a specific math use for our Roman numerals. Anytime we talk about it, it's going to be one of those 4. So really what we're looking at here, guys, is 6 things, 6 pieces that build up our coordinate plane, right? I have my 4 quadrants, 1, 2, 3, and 4. But I also have 2 additional pieces, don't I? I have my x-axis going left to right, and I have my y-axis going up and down. So those 6 pieces give me how I'm going to position anything within our coordinate plane. Couple notes. I don't necessarily have to plot a point to know where it is going to be found within my coordinate plane. For example, if I'm in quadrant 1, I know that it's got to be somewhere in this area, correct? So how do I get to that area? Well, if I start at origin, the only way to get to quadrant 1 is to go which direction? Right. So if I'm going right on x, what is that going to be? Positive or negative? Positive. So my x coordinate has to be positive to be in quadrant 1. Once I get over here, in order to actually get into quadrant 1, which way do I need to go? Up. So if I'm going up, what is my y coordinate going to be? It will also be positive. So these are the ones that you guys should have been graphing up to this point if you have done work on the coordinate plane. Any positive ordered pair will be in quadrant 1. Now let's look at quadrant 2. If I start at origin, yes, Emma? I just do random numbers. It's just any positive number on X, any positive number on Y will be in quadrant 1. Now, if I start at origin, in order to get to quadrant 2, which way am I going to have to go on my X-axis? Left. So that means that my X value is going to be what? Positive or negative? Negative. But once I get over here, to actually get up into quadrant 2, I have to go up, so my Y coordinate will be positive. So an example of a point that would be in quadrant 2 would be something like -1, 4. A negative X and a positive Y. Okay? Now let's go to quadrant 3. Again, if I start at origin, in order to get to quadrant 3 down here, which way am I going to have to go? Left. So that means my X value is going to be negative. Once I'm over here, to get down into quadrant 3, I'm going to go down or negative. So to be in quadrant 3, my point must have both a negative X value and a negative Y value. And then for our last one, in quadrant 4, again, I start at origin. So to get to quadrant 4, I'm going to have to go right, making my X a positive. But then I've got to go down to get to the quadrant, meaning my Y will be a negative. So something like 3, -2. Yes? This will definitely be a part of the next quick test. Okay, now let's talk about actually graphing our ordered pairs. In order to graph an ordered pair, let me just take a quick side note. We've been together for a little over a semester, right? Almost 3/4 at this point, believe it or not. I would hope at this point you guys have some respect for me as a mathematician, right? You guys feel like I know my stuff? Mathematician, not magician. Now, why do I bring this up? Because I don't know why, but for some reason, you guys won't trust me when it comes to graphing. Please trust me. I'm a really good mathematician. I'm really good with numbers. And I still do this every time I graph a point. The very first thing I do if I'm going to graph a point is I take my pencil and I put it right here at origin. What ordered pair shows origin? 0, 0, because it's where those two number lines intersect. So I'm not going up and I'm not going left, right. Not going up, down, not going left, right. It starts right here. The next thing I'm going to do is I'm going to look at the first number. The first number in my ordered pair is going to tell me, am I going left or right? So if it's positive, which way am I going to go? Right. If it's negative, which way am I going to go? So the first number in my ordered pair, if it's positive, I'm going right. If it's negative, I'm going left. Okay? So let's just take, for example, our -1, 4. So I would start here at origin. Because my first number is a negative, that means I'm going left for 1. I then pause. I don't actually write anything. I just kind of hold my pencil there. And then I look at the second number. The second number is my Y. So from there, I'm going to go the distance and direction of my Y coordinate. If it's positive, which direction am I going to go for the Y? Up. I've already gone left or right. That's always the first thing I do. If it's negative, I'm going to go down. It's okay, Nate. We'll get some more practice for you. So let's just take a look. So -1, 4. I would start at origin. -1 means I'm going left 1 spot. 4 means I'm going up 4. So I then go 1, 2, 3, 4. Only after I have done both moves do I actually make my dot on the graph. Does that make sense? So in this case, I'm going to just throw a random letter. We'll call this letter A, because a lot of times if I'm going to be plotting points, I'm going to have multiples on the same coordinate plane. So I need to label my point as well. So whatever I'm using to label that point, I make sure that it's put there so I know which one I'm talking about. Is this, yes, Emma?
So when I learned it in fifth grade, my teacher said that was the bottom left corner that you started. but I never did this circle kind of thing.
Are you talking for the quadrants?
Don't know. I just used to learn at the bottom left corner, and then you could go up to the certain spot.
That's because you're only doing quadrant 1.
Oh, okay.
If you're only doing quadrant 1, then yeah, you would always start at that bottom left. But now that we're doing all 4 quadrants, you got to start in the middle, because that's going to be my starting point. Madison.
Can I see the open chair over there so I can actually see the board?
Sure.
I cannot see the board.
Okay. Okay, I'm going to do one for you guys, just to make sure you have an example and understand what's going on. So let's do this second one. So I have the letter Q here, right? I start at origin. I put my pencil right here in the middle. My first number is a 0. So where do I go? Nowhere. 0 means I don't move, right? My second one is a -4. So that means I'm going to go down. How many? 4. So I just count 1, 2, 3, 4. Once I have done that second move, that is where I make my label. Now here's an interesting one. Where is this at? Because it also asks, plot the ordered pairs and say what quadrant they belong to. What quadrant is that in? Emma? No? It's right in the middle. Good job, Micah. So what is right in the middle? What is it on? No? Origin's in the direct middle. What is it on? What did we say this was? Good job, JJ. So that one's actually on the y-axis. So that's kind of a trick question. That's why I wanted to start with that one for you guys. Does that make sense? Okay. You have 5 left to do. I'll give you guys 2 minutes. You may work together as a table. I'm going to go quick because this should be a check of your answers. But you will see I actually practice what I preach on this, guys. Every time I plot a point, where do we start? Origin. Yes. So as we look at this, my first point, I again start at origin. I put my pencil here. -3 means that I am going left. 1, 2, 3. +5 means I'm going up. So I go up 1, 2, 3, 4, 5. Only after I've done both moves do I put my dot in its place and label it. This is letter M. That was in quadrant 2. Okay? We already did the 0, -4. Our next one, again, my pencil goes back to origin. -6 means I'm going left. 1, 2, 3, 4, 5, 6. 0 means I'm not going anywhere else. So I draw my dot right there. I label it. That's R. That one is on that axis. That is on the x-axis. Okay? Next, I go back to origin. -2 means I'm going left. 1, 2. +4 means I'm going up. 1, 2, 3, 4. So right over here is letter P. That is in quadrant 2. Make sure you are using Roman numerals for these. Our next one, 0 means I'm not going anywhere. I stay right at origin. +5 means I'm going up. 1, 2, 3, 4, 5. I draw my dot. This is letter S. And that one is, again, on that y-axis, the one that's going up and down. And finally, for my last one, I go back to origin, go over 1, 2, 3, 4, 5. Next one is a +6. So I go up 1, 2, 3, 4, 5, 6. So even though it's right on the edge, I still know that that's within this section. That means it's a quadrant 1. Is this all making sense? Okay. So let's take a look. I need everybody to take out a blank piece of paper. You are going to label your blank piece of paper from numbers 1 through 20. And you are going to put your name on it. So I'll give you a minute to do that. So we're going to fly through this. I'm just giving you the answers, but I'm also going to try to help you understand why you might have gotten them wrong if you didn't get it correct. Mark the ones that you get wrong. You should have a marking pen out now, not a pencil. Okay, number 1. 5/2. I have to turn that into a mixed number. That makes it 2.5. So I'm going 2.5 over, up 3. That's point B. Answer is B. Number 2. Quadrant 3 tells me they both have to be negative. The only one with 2 negatives is C, Charlie. Number 3, the vertex. The easiest way to do this one, guys, is just go through the ones they gave you, see which one is a vertex. So negative 1/3, 1. I go over and up. That's not it. Negative 1 1/3. So I'm going over 4 lines, up 1. There we go. So I hit it on the second one. It's B. Quadrant 2 means positive x, negative y. Negative x, positive y. That's going to be B. So I'm going left and then up. Number 5, point M. I'm going over 1.5, down 1.5. So that's a positive 1.5, negative 1.5. Answer B. Bravo. 6. To get, guys, please stop the celebration. Just listen. Again, I apologize for going fast, but we're down to 12 minutes. I have to go over negative 5, up 2, negative 5, up 2 is positive, so that makes it D, delta. 7, vertex, again, that's one of those points at the edges. So 2 ways to do it. I'm just going to go through the points again. So I go negative 2.5, and then down 2. I hit it on the very first one. That's A. Quadrant 4, I'm going right, so it's positive, then down, so negative, positive x, negative y is delta. Number 9, quadrant 3, again, that's a double negative. Only double negative is answer delta, D. Negative 4, 3, I go over 4, up 3, that puts me at M. So that's answer Charlie for point M. Which one is inside? The key on this one, understanding by each line is actually 1/4. So I go left, 0.5 is over 2, down 1.25, that's in the circle, but I don't want that. Next one, over 1 line, up 3, that actually puts me in the trapezoid, outside of the circle, that's what I was looking for, it's bravo. This is one of the tougher ones on here, because without the actual points on there, without drawing on my papers, is going to make it difficult, but negative 4, 3 is up here, 1/2 and 4.5 is going to be right up in here. Negative 4, negative 3 is going to be down here. Then I can look at these next ones. One key is I know it's going to be somewhere at the 1/2 point, because I have one base of my trapezoid here, meaning the other trapezoid base has to be somewhere in here. So there's only 2 that have that. Negative 2 is going to put it right here. The problem with that is that actually ends up being a parallelogram, not a trapezoid. So if you put A, I'll take it, but the actual answer, or if you put C, I'll take it, but the actual answer is A. A is the actual answer. If you put C, that's acceptable. Or if you put both, I'd be okay with that too. Okay, number 11, or 13, sorry. They gave me 4 points, so I know this fourth one has to be here. So it's going to be positive 3 down 1.5. That gives us Charlie, C. The root, again, the easy one on this is just plot the points, see which one ends up on the line. So 0, negative 3, not even close to a line. 3, 3, I just missed it, so that's not it. 5, negative 2, ends up being right on that line. So again, it's C, Charlie. Number 15. Which one's at negative 2, 5? So I go left 2, up 5. That is W. So that means it's answer A, alpha. 16. Again, 3 vertices of a parallelogram. So I know it needs to be a parallelogram. That tells me the shape. Here is one base. That means the other base needs to be somewhere on this line. But it needs to be the same distance as what it is here, because that's one of the definitions of the parallelogram. Opposing sides are the same length. So I know it's going to be somewhere at the negative 3, which means it's either going to be A or C. If I go to negative 5, negative 3, that isn't the same distance as this. So that can't be it. So that means it has to be C, 5, negative 3. That was 16. Okay, last page on this. Quadrant 4, that's a positive x, then down for the y, so positive, negative. The only positive negative is delta, D. 18, negative 1, negative 1. One key on this is making sure you understand the factor, the scale factor, that it's every third line. Negative 2/3, negative 4/3 puts me right there. That's on the line. Bravo. Which one is on the star or located within the picture? Negative 1, 2, that's too high. 0, 2, that's too high. Negative 1, 0 puts me right here. That's outside of it, so it's not any of those. Delta. And he's plotting points. If I move left on the x-axis, that's a negative 9. Then I go up 5, that's a positive 5. So negative 9, positive 5. Bravo. Okay? So very quickly, total number correct on the top of your page. Make sure your name is on it and turn it into the box. Okay, the homework tonight needs a little more explanation. The battleship on the back, guys, this is optional. You don't have to do this. But if you choose to, it's actually pretty fun. It's just like the old game of Battleship. Here's the 4 ships you're going to put on it. All you do is you choose, but it has to go either up, down, or left, right. You cannot do diagonal. But I put in, say, for example, I have an aircraft carrier. So I'd start here. I go 5 spaces. So don't forget to count your endpoints. That's actually one too long. So 1, 2, 3, 4, 5. That would be my aircraft carrier. I do that with all 5 of the ships. Once both of you have all 5 of yours placed, you take turns alternating back and forth, calling out grid coordinates to figure out if they have a hit or a miss. If they hit one of those 5 that covers your ship, that's a hit, including those 2 end ones. If not, it's a miss. Then you just take turns until somebody sinks all of the ships for the other guy. Optional, you do not have to do that. Here is the beginning of your homework, okay? On this page, you'll see that there are 6 shapes. The way these shapes work, I'm just going to start at the first ordered pair that is listed, in this case 4, 6. So starting at origin, I go over 4, up 6, and I draw my dot. I go to the next one, 6, 6. So over 6, up 6, and then between them, I connect the dots. So yeah, it's kind of like connecting the dots. Okay? I'm going to keep doing that. So then my next one is 6, 7. I draw that one. Then I go to 4, 7. 4, 7. I connect those dots. Then you'll see that word stop. Once I stop, I'm going to restart my next piece of the drawing. Make sense? Don't connect the dots between 4, 7 and negative 3, 7. That's going to be a whole separate shape. So you're going to have 6 shapes. When you draw them all together, it comes out to a shape you should recognize. Here's the last part. Oopsie, I forgot to erase this one. I'm going to show you anyway, but this is one of those self-correcting ones, guys. So you're going to be able to see the answer. If the answer you get is not listed, that means you're wrong. Okay? All you're doing is finding where the ordered pair is for the point that is on that graph. So in this case, the A is up here, so I'm going to go right 3, up 5. So that means my ordered pair is 3, 5. So I'm going to go to this direction. I color this one in. Then I go to my next one. From here, again, I always start at origin. I go 3 left. That makes it a negative 3. But then I'm not going to go anywhere up or down. So that makes it a negative 3, 0. So I look at all the different ones. Here's my negative 3, 0. So this is the one I'm going to go down. Make sense? So you're going to go all the way through here, and you're going to end in the finish. I will give you a hint. If you finish in under 7 spots, you did it wrong. So if you finish in under 7 spots, go back and check your work. It means you messed one of them up. Any questions on your homework? Okay, you guys actually have about 3 minutes left. If you want, you can probably finish this one, or you can get a good start on the drawing one. But you got 3 minutes to keep working on your homework.